So for our second unit, we're going to start with a little bit of a review of rigid motions. So it first asks what transformation is pictured in the graph, right? So we can see basically as I map from A to X, B to Y, and C to Z, that there is a turn as we move from each image. So because of this, we know that it is a rotation. And because it is a rotation, this is a rigid motion. Therefore, I know that the triangles are congruent. They are the same shape and they are the same size. So again, congruent, equal in size and shape, distance and angles are preserved. And now corresponding parts are going to be important as we move forward in this unit. This says that the matching pieces, either the angles or the sides of congruent polygons. So for example, when I mapped from ABC to XYZ, the order tells me the corresponding parts. A mapped to X because they come first. B mapped to Y because they came second. And then C mapped to Z. So congruent triangles are triangles that are the same shape and size. If all measures of the corresponding parts of two triangles are congruent, then the triangles are congruent. So what is that saying? That's saying that if all of the sides that correspond, so if this side maps to this side, and they are congruent, and that is the same for every side and every angle, then they must be congruent. Basically, if all of the sides and angles are congruent in both triangles, the triangles are congruent, which makes sense because if everything is the same size and shape, then they are congruent. So this is an example. So if we know that triangle ABC is congruent to triangle XYZ, again, the order tells me what is congruent. A maps to X, so you know right away that angle A is congruent to angle X. Now, when you look at the segments AB, XY, so AB is congruent to XY. BC corresponds to YZ. Therefore, BC is congruent to YZ. I can say this all because I already know that the triangles are congruent. If the triangles are congruent, then all of the corresponding sides need to be congruent as well as their corresponding angles. Right? The angles are a little bit easier to see because it's 1, 2, 3, 1, 2, 3. The sides get a little tricky when you go for the last one because you say AB, then BC, but then you have to go AC is congruent to XC. Again, the order matters. Please make sure that you are making sure that the order is the same when you are writing all of your proofs as we move on. So now you are to match to name the corresponding angle or side based off of the definition. So they gave us FD for the first one. See how I highlighted F and D? It tells me the matching letters. And I kept the order the same. F came first, so I comes first, then K. Same thing here. Angle A is in the middle. Angle M is in the middle. So angle M must be congruent to angle M because they are corresponding. Again, angle U is in the middle. Angle F is in the middle. Corresponding, congruent. Angle W is first. Angle G is first. Corresponding, congruent. Angle Y is last. C is last. Corresponding angles are congruent. Therefore, angle Y is congruent to angle C. Same thing again. They give you the congruent statement of the triangles. You have to find the corresponding parts. Angle F corresponds to angle R, so they are congruent. Now, this whole unit is called Triangle Congruence because we are going to be proving that triangles are congruent using some of these theorems. So the first way that you can prove that triangles are congruent is by proving that all three sides are congruent. The second one is proving that there is two sides and the angle that is in between them. So if we look here, this angle is in between the two congruent sides, and it's the same in both of them. That is side, angle, side. There's a little sandwich. Similarly, for angle, side, angle, when the side that is congruent, the corresponding congruent side, is in between two corresponding congruent angles, that is another way that you can show that two triangles are congruent. Angle, angle, side. So if there are two congruent angles and then a congruent side, that is another way to show that two triangles will be congruent. For right triangles only, if you can show that the hypotenuse, which is the side across from the right angle, and a leg are congruent, then you would know that this is a congruent right triangle pair. So reasons for congruent sides, the reason why you can say that two sides are congruent. So this is talking about when you're writing your two-column proof, what could be on the reason side. So it could be given that two sides are congruent. You could be given a midpoint and also a bisector. If there is a midpoint or a bisector, you would know that there are two sides that are congruent. And you can also use the reflexive property. We saw that example in lesson 1. When there was an altitude, you can say that that altitude is equal to itself. Therefore, you have two congruent sides. Reasons for congruent angles, again, if it's given. Vertical angles. If you're dealing with parallel lines, there is a reference at the beginning of the packet if you don't remember. So for alternate interior angles, as well as corresponding angles. And again, if you have a bisector, that creates two congruent angles. And again, some more practice of finding the corresponding parts. AB comes first, DE comes first. So AB is congruent to DE. A and D are congruent. B and E are congruent angles. C and F are congruent angles. And the same thing for the rest of the segments. So using that information, we can look at these and tell what we would use, right? So again, so the little tick marks, if there's one, that says that these two are congruent. If there are two, these two are congruent, and the similar thing for angles. So if I label this, I know that there's a side, an angle, and a side. Since it is that little sandwich, I could use that side, angle, side to prove that these two are congruent. Similarly here, 1, 2, 3, side, side, side. I see a right angle, so I know it is a right triangle. If I have a leg and a hypotenuse in both triangles, I can use HL. Some multiple choice Regents questions. So these are questions that may pop up on the Regents exam. So in the diagram below, triangle ABC is congruent to triangle XYZ. So again, order matters. Which statement must be true? First, they say that C is equal to Y. That can't be true because C is the third letter and Y is the second. So those do not work. Number 2, A is the first, X is the first. So right off the bat, I know angle X and angle A have to be congruent because they are corresponding in congruent triangles. So now we have to start marking up our diagrams. They said that AC bisects BAD. So AC bisects BAD. So that's why I drew here, because I know that these two angles are congruent. I know that AC is the same in both, so I already have an angle and a side. And they also gave me that B and D are congruent. So I have an A and S and an A. But if you look, the side is not wedged between the two angles. So if I read, it should be angle, angle, side. So again, they give us congruent triangles and asking us for the corresponding congruent parts. So I crossed off 1 because just looking at the angles is the quickest way. C is the third, Y is the second, not corresponding, not going to be my answer. C and X, 3 and 1, not corresponding, not going to be my answer. And you can even look between these two, A and Y, 1 and 2, not corresponding, not going to be congruent. Just by looking at the angles, I was able to find my answer. That is 4. BC is congruent to YZ, and A is congruent to X. In the diagram below, triangle AGE and triangle OLD, we know that angle GAE is congruent to LOD. So I have this marked here. I start with one congruent angle. You also know that AE is congruent to OD. Now they're saying that they want to prove their congruence by side, angle, side. So I have a side here and angle here. So I would need these two sides to be congruent in order to use that theorem. This side is AG, this side is OL. Therefore, I would need number 2 to be true in order to use that theorem.